Hello friends, welcome to EC Academy. In this lecture, let us understand Radix-2 DIT FFT algorithm. Here DIT represents decimation in time and FFT represents fast Fourier transform. This approach depends upon decomposing the DFT into successive small DFTs. So, we will take a DFT and that DFT will be decomposed into successive small DFTs. For example, if we take 8-point DFT, that DFT will be decomposed into 4-point DFT, then it is decomposed into 2-point DFT. So, this 8-point, 4-point and 2-point are in the powers of 2. That is why it is known as Radix-2 DIT FFT. Now, let us consider x of n of length n. So, we can write x of n is equal to x of 0, x of 1, x of 2, x of 3 and so on, x of n minus 2, comma, x of n minus 1. So, these are the samples of n point sequence x of n. Now, let us decimate this x of n into two sequences of length n by 2. So, this is the sequence of length n. Now, let us decompose or let us decimate x of n into two sequence of length n by 2. So, the two sequences are even indexed sequence and odd indexed sequence. In this, x of 0, x of 2, x of 4 and so on up to x of n minus 2 will be even index sequence, x of 1, x of 2 and so on up to x of n minus 1 are the odd indexed sequence. So, while calculating the even indexed and odd indexed sequence, you should not look at 0, 1, 2 and 3. Instead of that, you need to look at the position of each sample. So, the position of each sample will decide whether this is the even sample or an odd sample. So, depending upon the position, we will decide this is even sample and this is odd sample. Let us write even indexed sequence as x of 0, x of 2, x of 4 and so on up to x of n minus 2. We can write odd index sequence as x of 1, x of 3, x of 5 and so on up to x of n minus 1. We know that n point DFT can be given as x of k is equal to summation of n is equal to 0 to n minus 1 x of n wn to the power of kn for k value ranging from 0 to n minus 1. Let us call this as equation number 1. Now, let us decimate equation 1 into even indexed and odd indexed sequence. So, let us decimate equation 1 into even indexed and odd indexed sequence. So, we can write the above equation as x of k is equal to summation of n is equal to 0 to n minus 2 x of n wn to the power of kn plus summation of n is equal to 1 to n minus 1 x of n wn to the power of kn. Let us call this as equation number 2. Here for even index sequence n value is from 0 to n minus 2 for the summation. So, this value we have taken from this sequence. You can observe here n value is 0 here and it is up to n minus 2. So, that is why we have taken summation as n is equal to 0 to n minus 2 for even index sequence. Here n will be even, and for odd index sequence we have taken the value of n from n is equal to 1 to n minus 1. You can observe here n value is from 1 to n minus 1. So, that is why we have written n is equal to 1 to n minus 1. So, here n value will be odd. Now, let us put n is equal to 2r in first term of equation 2 and n is equal to 2r plus 1 in second term of equation 2. So, in first term we will replace n by 2r and in the second term we will replace n by 2r plus 1. So, since the second term is the odd sequence, it will represent the odd sequence, that is why we have taken it as 2r plus 1. So, for any value if you add 1 it will be an odd value. So, that is why we have taken 2r plus 1. Now, we can write the above equation as x of k is equal to summation of. So, here what we are doing, n is replaced with 2r. So, if you put 2r is equal to 0, we can write r is equal to 0. That is why we can write r is equal to 0 for the upper summation limit. So, we can write 2r is equal to n minus 2. So, from this we can write r is equal to n by 2 minus 1. So, it will be n by 2 minus 1 x of 2r wn to the power of 2 kr, because n is replaced with 2r, plus summation of r is equal to 0 to n by 2 minus 1, because if you replace n with 2r plus 1, it will be 2r plus 1 will be equal to 1, 2r will be equal to 0, r will be equal to 0. So, that is what we have written here. For the upper summation limit, we can write 2r plus 1 will be equal to n minus 1, 2r will be equal to n minus 2, r will be equal to n by 2 minus 1. So, that is why for the upper limit we have written it as n by 2 minus 1. X of 2r plus 1 wn to the power of k into 2r plus 1. Let us call this as equation number 3. Let us replace x of 2r with g of r and x of 2r plus 1 with h of r. So, we can write the above equation as x of k is equal to summation of r is equal to 0 to n by 2 minus 1 g of r wn to the power of 2 k r plus summation of r is equal to 0 to n by 2 minus 1 h of r wn to the power of k into 2r plus 1. Now, in this equation we can replace this term, or we can rewrite this term as wn to the power of 2 kr, wn to the power of 2 kr into wn to the power of k. Since wn is equal to e to the power of minus j 2 pi by n, we can write wn to the power of 2 as e to the power of minus j 2 pi by n into 2. So, this term we can write it as e to the power of minus j 2 pi by n by 2. So, this is nothing but we can write it as wn by 2. Since in place of n we are having n by 2, we can write this as wn by 2. So, that is why in the above equation wn to the power of 2 can be written as wn by 2. So, we can rearrange the equation and we can write it as x of k is equal to summation of r is equal to 0 to n by 2 minus 1 g of r w n by 2 to the power of k r plus w n to the power of k. We have written this term into summation of r is equal to 0 to n by 2 minus 1 h of r w n by 2 to the power of k r. Let us call this as equation number 4. In this equation 4, this term is n by 2 DFT of even sequence, and this term is n by 2 DFT of odd sequence. Now, we can simplify the above equation and we can write that as x of k is equal to g of k plus w n to the power of k h of k. So, here g of k is the DFT of g of r and h of k is the DFT of h of r. Here the value of k is ranging from 0 to n by 2 minus 1. Here both g of k and h of k are periodic signal with period n by 2. So, it is periodic with period n by 2. So, that is why we can write this equation as x of k is equal to g of k minus n by 2 plus w n to the power of k into h of k minus n by 2. So, here the value of k is ranging from n by 2 to n minus 1. Let us call this as equation number 5 and let us call this as equation number 6. So, this is from periodicity property. Now, for example, let us take n is equal to 8. Therefore, the value of k will vary from 0 to 7. So, we need to put the value of k is equal to 0 to 3 in equation number 5 and we need to put k value from 4 to 7 in equation number 6. Now, let us take equation number 5. In this equation, if you put k is equal to 0, you will get x of 0 will be equal to g of 0 plus w8 because n is taken as 8, w8 to the power of 0 h of 0. If you put k is equal to 1, at that case x of 1 will be equal to g of 1 plus w8 to the power of 1 h of 1. If you put k is equal to 2, at that case x of 2 will be equal to g of 2 plus w8 to the power of 2 h of 2. If you put k is equal to 3, at that case x of 3 will be equal to g of 3 plus w8 to the power of 3 h of 3. If you take equation number 6 and if you put k is equal to 4, at that case x of 4 will be equal to simplify equation number 6, if you put n is equal to 8 here, this equation will be g of k minus 4 and this will be h of k minus 4. So, in this equation if you put k is equal to 4, you will get g of 0 plus w8 to the power of 4 h of 0. If you put k is equal to 5, so it will be x of 5 will be equal to, if you put 5 here, so it will be g of 1 plus w8 to the power of 5 h of 1. If you put k is equal to 6, it will be x of 6 will be equal to g of 2 plus w8 to the power of 6 h of 2. If you put k is equal to 7, it will be x of 7, that will be equal to g of 3 plus w8 to the power of 7 h of 3. Now these equations we can represent using signal flow graph. Let us write the signal flow graph for this. So how many values we are having? We are having 4 values. So we will take 4 values and we will take these 4 values separately. For the first block, the inputs are the even sequence values, and for the second block, the inputs are the odd sequence value. So here we have taken only 8 values here because we have taken 8 point DFT. So these are even sequence values and these are odd sequence values. So that's why we will get x of 0, x of 2, x of 4, x of 6. Here we will get x of 1, x of 3, x of 5 and x of 7. Now let us extend these lines. So the output values are x of 0, x of 1, x of 2 and x of 3. Also it will be x of 4, x of 5, x of 6 and x of 7. Let us write that. So here we will write g of 0, g of 1, g of 2, g of 3. Here we will write h of 0, h of 1, h of 2, h of 3. So this is n by 2, which means 4 point DFT, and this is again n by 2, which is 4 point DFT. To get the output x of 0, we should have g of 0 plus w8 to the power of 0 into h of 0. So we are having g of 0 here. Let us take this, and we are having h of 0. Let us join these two and let us write here w8 to the power of 0. So it will be g of 0 plus h of 0 into w8 to the power of 0. So that will give x of 0. Similarly, we can write it for x of 1 as g of 1 plus w8 to the power of 1 into h of 1. So we can join these two. And here we can write w8 to the power of 1, we can join these two. So with w8 to the power of 2. In the same way we can join these 2 points and we can write here w8 to the power of 3 to get this equation. To get this equation, x of 4, it is g of 0 plus w8 to the power of 4 into h of 0. So we are having g of 0 here and we are having h of 0 here. So we can join these two, and the scaling factor is w8 to the power of 4. The same way we can join these two, and we can join here like this. So we can write the scaling factor for each. So it will be w8 to the power of 5. It will be w8 to the power of 6 and it will be w8 to the power of 7. So this is the first stage in DIT FFT for n is equal to 8. Since g of k and h of k are n by 2 point sequence. So this can be represented as combination of n by 4 points. So we will take 2 n by 4 points and represent g of k and h of k. Let us write g of k can be written as summation of r is equal to 0 to n by 2 minus 1 g of r Wn by 2 to the power of kr. Let us call this as equation number 7. Let us represent equation 7 as even indexed and odd indexed sequence as g of k is equal to summation of r is equal to 0 to n by 2 minus 1 g of r into Wn by 2 to the power of kr plus summation of r is equal to 0 to n by 2 minus 1 g of r wn by 2 to the power of kr. Since we are taking the sequence g of r, that can be represented as g of 0, g of 1, g of 2 and so on up to g of n by 2 minus 2 comma g of n by 2 minus 1. Here these are the even sequence and these are the odd sequence. So that is why the even sequence value should repeat from 0 to n by 2 minus 2 here. So you can see here n value is up to n by 2 minus 2. For the odd sequence, r value should be from 1 to n by 2 minus 1. So this is the even and odd representation of equation 7. Let us put r is equal to 2l in first term and r is equal to 2l plus 1 in second term of equation number 7. So at that case g of k will be equal to summation of l is equal to 0 to n by 4 minus 1 g of l wn by 2 to the power of 2 kl plus summation of l is equal to 0 to n by 4 minus 1 g of 2l plus 1 into wn by 2 to the power of k into 2l plus 1. So the lower summation, if you put r is equal to 2l, so it will be 2l is equal to 0, so it will be l is equal to 0. So that is why we have written l is equal to 0 here, and at the upper summation it will be 2l is equal to n by 2 minus 2. From this we can write l is equal to n by 4 minus 1. So that is what we have written here, and here if you put 2l plus 1 is equal to 1, from this we can write l is equal to 0. So that is what we have written here. For the upper summation it will be 2l plus 1 will be equal to n by 2 minus 1. So we can write 2l is equal to n by 2 minus 2, l is equal to n by 4 minus 1. So that is what we have written at the upper summation. This term wn by 2 to the power of 2 can be written as wn by 4. So we have replaced that term here in this equation. We have replaced here, and this term we can write it as a of l, and this term we can write it as b of l. So we have written those two terms here, and we have written this equation. Now this entire term we can write it as a of k, and this entire term we can write it as b of k. So we can write g of k is equal to a of k plus wn by 2 to the power of k b of k. Here the value of k will be ranging from 0 to n by 4 minus 1. Let us call this as equation number 8. Here a of k is n by 4 point DFT of the even index sequence, and b of k is the n by 4 point DFT of odd indexed sequence. Similarly, we can write it for h of k as we will take the new term as c of k plus wn by 2 to the power of k d of k for k value ranging from 0 to n by 4 minus 1. Let us call this as equation number 9. Here a of k, b of k, c of k and d of k are periodic with period n by 4. Hence we can write equation number 8 as g of k is equal to a of k minus n by 4 plus wn by 2 to the power of k, b of k minus n by 4 for n value ranging from n by 4 to n by 2 minus 1. Let us call this as equation number 10, and equation 9 can be written as h of k is equal to a of k minus n by 4 plus wn by 2 to the power of k, d of k minus n by 4 for k value ranging from n by 4 to n by 2 minus 1. Let us call this as equation number 11. Here we need to put k value is equal to 0 and 1 for equation number 8 and 9, and we need to put k value is equal to 2 and 3 for equation number 10 and 11. Let us consider equation number 8. If we put k is equal to 0, at that case we will get g of 0 is equal to a of 0 plus w4 to the power of 0. Here it is n by 2, n value is taken as 8. So, it will be 8 by 2, it will be 4. So, that is why we have written w4, k value is 0. So, w4 to the power of 0 into b of 0. K is equal to 1, at that case g of 1 will be equal to a of 1 plus w4 to the power of 1, b of 1. In equation 10, this is equation number 10. If you put k is equal to 2, here the term will be a of k minus 2, here it will be b of k minus 2 because n is equal to 8. Here it is c, so you can write it as, here it will be c of k minus 2 and here it will be d of k minus 2. So, in equation number 10, if you put k is equal to 2, it will be a of 0 plus w4 to the power of 2, b of 0. If you put k is equal to 3, at that case it will be g of 3 will be equal to a of 1 plus w4 to the power of 3, b of 1. In equation number 9, if you put k is equal to 0, it will be h of 0 is equal to c of 0 plus w4 to the power of 0, d of 0. If you put k is equal to 1, it will be h of 1 will be equal to c of 1 plus w4 to the power of 1, d of 1. In equation number 11, if you put k is equal to 2, it will be h of 2 will be equal to c of 0 plus w4 to the power of 2, d of 0. If you put k is equal to 3, it will be h of 3 that will be equal to c of 1 plus w4 to the power of 3, d of 1. For this, let us write the signal flow graph. Let us divide it into 4 blocks. Each block will be having 2 inputs. To write the inputs, we will write it as x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. So, here what we have done, we will take even and odd sequence of x of n. So, even sequence is x of 0, x of 2, x of 4, x of 6 and odd sequence is x of 1, x of 3, x of 5 and x of 7. In this sequence again we have divided it into even sequence and odd sequence for these two. So, here it is even sequence and this is taken as odd sequence. So, even sequence is x of 0 and x of 4. So, that is what we have written here, and odd sequence is x of 2 and x of 6 So, we have written that value. Again, in this odd sequence, it is divided as even sequence and odd sequence. So, here x of 1 and x of 5 are taken as even samples, and x of 3 and x of 7 are taken as odd samples. So, x of 1 and x of 5 we have written here, and x of 3 and x of 7 we have written here. So, let us extend these input lines. So, let us write here a of 0, a of 1, b of 0, b of 1, c of 0, c of 1, d of 0, d of 1. So, here it will be g of 0, g of 1, g of 2, g of 3, now to get the output g of 0, we should have a of 0 plus w4 to the power of 0, b of 0. So, this is a of 0, we can join these two and we can write w4 to the power of 0. Again, to get second equation, so we can join these 2 points and we can write w4 to the power of 1. To get this third equation, g of 2, so we can join these two and we can write the scaling factor as w4 to the power of 2, and we can join these 2 points and we can write the scaling factor as w4 to the power of 3. In the same way, we can join these two, and here we can join these 2 points, and here it will be w4 to the power of 0, w4 to the power of 1, w4 to the power of 2, w4 to the power of 3. So, this is the second stage of decimation. So, we need to continue the simplification process. We will do that in the next lecture. Hope you have understood this topic. Thank you.